convex mirror, that we can see the image behind with a small image. So what? You can see all street behind the driver. So it will diverge rays to form small image for the street behind. It's called convex mirror. So what are the rays? What are the paths of reflected rays through convex mirror? Okay, observe what happens as we draw in the concave mirror. It's a convex mirror, and also its optical axis and the focal point. What happens to light rays? Does convex mirror converge rays or diverge rays? Observe what happens. It's the first ray, yes, parallel to the principal axis, it will diverge. But its extension of reflected rays, this is called reflected rays. The extension of reflected rays will pass by focal point. Another drawing, parallel to the principal axis, okay, it will diverge. But its extension will pass with the focal point. This is optical axis reflecting itself as we studied before. Another ray falls parallel to the principal, reflect, okay, but its extension passes the focal point. And this again, okay, parallel to the principal axis, reflect, where its extension will pass with focal point. So its focal point called virtual, not real, as concave mirror. Why? Because it's produced from what? Yes, virtual image. Good, because it's the image produced from the intersection of extension of reflected rays. But in concave mirror was what? Yes, produced from the intersection of reflected rays. So it's the difference between them. In concave mirror, from the intersection of reflected rays, but when convex mirror, it's collected by the intersection of extension of reflected rays. So difference between them in the concave and convex mirror. Understand? So we have two types of image. Okay, in concave mirror we said that it's a real image. Okay, but in convex mirror we said that it's a virtual image. What are the differences between these two images? Okay, listen please. The image a concave mirror forms depends on the object's location relative to the focal point. The image is virtual. Why? Why is virtual? The image virtual if the object is between focal point and the mirror. The image is real if the object is B. One is B. Yeah, the focal point. Real image. What's meant by real image? Real image, an image that forms where rays converge. Okay, but is one of that forms when rays converge. No image forms if the object has a focal point. Okay, observe what happens to get this. Okay, if we put the object left of the focal point here, what happens? This is the object left the focal point. The first ray parallel to the principal, it will reflect passing through the focus. Another ray passing through the focus, it will reflect parallel to the principal axis. The intersection between two rays is the image formant. So what are the properties of image formant? Okay, according to size, according to direction, okay, according to its position, okay, and according to its real or virtual image. First, it's real image. Why? Yes, because it's produced from the intersection of reflected rays. This incident, this reflected. This incident, this reflected. So the image formed from the intersection of reflected rays. So it's called real image, not virtual. It's the first one. The second one, okay, the second is the image inverted. Okay, inverted. What's meant by inverted? It's the image, its head at the top, but this, its head was down, so it's called inverted. Number 3, it larger, the image larger than the object, larger than the object. Okay, so it's found behind the image. Okay, so the properties of image formed through concave mirror where the object was left of the focal point. Okay, understand? What happens if you put this object at the focal point? Observe. No image will be formed. Why? Because it's the object at focal point. The first ray parallel to the principal, it will reflect passing through the focus. What about the intersection of reflected rays? If you draw another ray passes through the center, okay, it will pass in a straight line. Its reflection will pass in a straight line, and this in a straight line. So there is no B intersection between them. So there is no image formed. There is no image formed here. It's okay. How? If you draw what? If you draw another, this is the focal point, and this is center, because center doubled focal point. If you draw this ray, okay, when it passes through the center, it will pass on a reflecting surface, okay, so it will be straight. Its reflection will be like this. And if you make the extension of reflected rays, it will be this. So what happens? There is no image formed because there would be no intersection between these extension rays. So there would be no image formed if the object put at the focal point. It's okay? Understand? After that, what happens if you put the object at right of the focal point, at the right? What happens? Okay, this is the first, will be at this. Okay, if you draw another ray at this is the focal point, we said, and this is the focal, this is the center. Okay, if you put another ray from the object to the center, it will be reflects on itself. So this is its extension, and this is the extension of this reflected rays. So the extension, the intersection will be this. So it's the image formed. That will be virtual or real. Good, virtual. Why virtual? Why virtual? Yes, because it's produced from the intersection of extension of reflected rays. Okay, so they are the rays, okay, the rays formed through the concave mirror. If you put the object first at the left side of the focal point, second at the focal point, third between mirror and focal point. Understand? Okay, any problem till now? It's okay. This is the image formed through concave mirror. Okay, after that, inshallah, we are going to make a model what happens to light in a convex mirror. Okay, this is explained, there words explained, and this is explained. Okay, after that, how does the way light reflects off curved mirror help explain why eyes sometimes appear to glow in the dark? Record your evidence B in the chart at the beginning of the lesson that we studied, okay? And I will check for the evidence, okay? This is a rough surface, that we are going to study in the next time, inshallah. Okay, this is what we said. Spherical mirror, concave and convex. Sphere is silvered on the outside to form a reflective surface on the convex mirror. The sphere is silvered on the inside to form a reflective surface on the concave mirror. There's a difference between them. So concave mirror, as we said, it's called converging mirror, but this is called what? Called converging mirror. Okay? This is a rays that we said before. Converging mirror, that's concave mirror, is one of that spherical in the nature by which it can focus parallel light rays to a point directly in front of the surface. Every spherical mirror can do this, and this special point is at fixed position for every mirror. We call this point as the focal point, as we said before. To find this point, you must use light from infinity. Okay, this rays through the concave mirror. After that, okay, this is the converging mirror. That rays falls on concave mirror and will be reflected again to intersect in one point called focus. As a converging mirror through concave mirror. Okay, this is the rays that we studied before. If you put the object at the left side of the focus, okay, and this is the principal axis. All this we studied. Okay, this is what happens to this, the intersection. So it's called real image, not virtual image. Okay, after that, this is another ray. The same intersection. This is another ray in the same intersection. Okay. So they are studied. Okay, at the end. Understand? Okay. So we studied spherical mirror, the difference between concave and convex mirrors, and paths of light rays through spherical mirror. Okay, now we end this session, and we are going to complete, inshallah, another session, part 3, in next time, inshallah. Okay, good luck for grade 8, and see you soon. Okay, goodbye.